Hi everyone. I'm going to walk through two of the problems from last Wednesday's quiz that gave a number of students a little bit of difficulty. So the first one was an array problem that is to compare two arrays and check each corresponding pair of values in the array and count up the number where the first value is smaller than the second value. So in this case, for example, we have two arrays, 10, 20, and 15, 16. So we're going to compare the 10 and the 15. And since 10 is less than 15, we'll count that. And then the second pair is 20 and 16. And because 20 is not less than 16, we won't count that. So that gives us a total of 1 as an answer. Just that pair, 10, 15. Now, the thing to realize here is that, yes, we do need to iterate through both lists, but we can only iterate through one list at a time in a loop. So, in my opinion, the easiest way to do that is to just pick one. Now, the problem does say that you can assume both lists are the same length. So we're just going to pick list 1 and iterate through list 1, but we're going to use an index to do that. So for I in range 0 to length of list 1. So we'll get all of the indexes for the first list. And because the second list is the same length, they'll work for the second list. So then we can just compare the first elements of each list, the second elements of each list, the third elements of each list, and so on by doing if element I of list 1 is less than element I of list 2. That's what we're looking for, right? The value of list 1 is smaller than the corresponding value in list 2. And if that's the case, we'll just add 1 to our count. And when we're done, we can return the count. Need to initialize count there. All right, and then we can test this out quickly. These two. So let's see what should happen here. We're going to compare 1 and 2, 5 and 3, 7 and 4, 9 and 10. And let's see, 1 is less than 2, 9 is less than 10, but 5 is bigger than 3, 7 is bigger than 4. So this should give us an answer of 2. And we get 2. Oh, let's do one more just to make sure the problem's clear. So all the values in the first list are 10, and those values are smaller than 11, 12, and 13. They're larger than 8 and 9. So when we run this, we should get 3. Okay, so that's the idea of that problem. And again, the key idea here is, even if we're looking through two lists, the for loop that you're writing has to focus on one of those lists. There really isn't a great syntax for looking at two lists at once. Yes, there is a zip function, so there are times when that might be helpful. But for the most part, unless you have a good understanding of what the zip function does, you want to just set up a loop with an index like we did here, loop through one of the lists, and then look at the corresponding elements in the other list. All right, and I'm also going to go through one of the dictionary problems. The basic idea of this problem is that you're given a dictionary, and we're going to iterate through that dictionary and update some of the values so that each value is at minimum 3.5%. Now, there's a couple of ways of doing this. So I'm going to take what I think is the conceptually simplest approach and iterate through the keys of this dictionary. So for key in, so just iterate over the keys. Now, what I need to know for each key is whether the value is above or below the minimum. In particular, if it's below the minimum, we need to take action. So if proposed increase key, which gives us the value, so if the value we're looking at is below the minimum increase, we need to reset that value. And that's really all we're doing. Notice we're not building a new dictionary. We're modifying the dictionary we have, but it does say it should return. So I'm going to put a return statement here. This could also work with having a none return and just simply modifying the increase. I could have written it either way. All right, so let's make sure this works. And so let's see. Grand Valley stays at 3.5. Michigan stays at 4. Michigan stays at 4.5. Ferris goes to 3.5. Hope goes to 3.5. Calvin goes to 3.5. Okay, so this one did work. So the two main ideas being emphasized here are accessing values given a key and modifying a value given a key. Now, I think it might be helpful to show one other way of doing this. I don't know that this is necessarily a better way of doing it, but if you like it, you're welcome to use it. We can iterate over the keys and the values together by calling the items function. And now I can look at the value directly. The thing I want to emphasize here, though, is although I can look at the value directly, if I want to modify the value, I have to go through the dictionary. I have to access the dictionary through those square brackets. I can't simply change the value. Value is a reference to the same object, but if I say value equals, what that's going to do is it's going to reassign the object that value references. It's not going to modify anything in the dictionary itself. Here, let's make sure this still works. And it did give us the correct answer. Here, let me do this just to emphasize what I just said. So notice that this is incorrect. Here, let me make sure that it's perfectly clear that I'm about to write some incorrect code. If I say value equals, notice down here that the values didn't change. Grand Valley still at 1.5%, Hope still at 2.5%. So if you want to modify a dictionary, you have to actually call a method on the dictionary. You can't use the reference that comes out of the items iterator. I didn't see any of that on this particular quiz, but I figured it was a good idea to mention it while I had it up here on the screen. So those were the two problems that gave students the most difficulty on this last quiz. So hopefully you have a chance to look through this before Wednesday's quiz. Of course, let me know if anything warrants further clarification in class.